Hello, my name is Tarang Vaish and I'm an engineer here at Cohesity, and I want to talk about fault tolerance in the Cohesity system. On my right, I am showing an example of a Cohesity system where we have multiple nodes with few disks inside each node. The nodes can always be scalably increased in the system, and we can end up with tens or even hundreds of nodes in the system. So how do we make sure that we are resilient against faults in such a system where we have so many running components in the system? So let's start with the smallest fault domain, which is a disk. A disk can always go bad due to bit rots, due to mechanical failures or power failures, etc. When a bunch of disks are present in a node, then node failures become critical as well, because now you have more data that could be unavailable. And so on, where you can have multiple nodes in a rack, and racks could be in a chassis, and chassis could be in a data center. They're all prone to faults, but the chances of failures keep going down as we go up the ranks. But we want to make sure that we are protected against any such faults in the system. So let's talk about how Cohesity by design is created to make sure we are resilient to any such faults. So what do you mean by resilient to faults? The first item is that there should be no data loss in the system. And the second item is that the data should be always available. So if a disk goes bad, if the data you are trying to access was on that disk, there should be another copy in the system which should be able to recover that data and be able to service right away without any pause. So by design, Cohesity is a distributed system, which also means that there is no single point of failure. So at any point of time, a single disk could fail, a node could fail, or higher constructs can fail, and we should still be able to function properly. Then from there on, we have the concepts of fault domains, which are disks, node, chassis, and racks. So when the data comes onto the Cohesity system, we first make sure that the copies of the data are not present on the same disk, because if a single disk fails, then we can have data loss. Then we make sure that the copies of the data are not present on the same node. And if we need more fault tolerance, we make sure they are not present in the same chassis or rack. Along with that, you can have a disaster recovery scheme where you can frequently copy the system to another Cohesity cluster on a remote data center and make sure that your data is well preserved. Along with this, what you also care about is the active fault tolerance, means that the system is able to repair itself as quickly as possible. So let's take an example where a disk goes bad. So when a disk goes bad, then the copy that was present on that disk is no longer available, and all the data that was on that disk is actually spread out on all the other disks in the cluster. So actually, the repair procedure can take the data from all other disks and quickly recover and repair the system, because every node is participating in the repair of the single disk failure I explained. So this way, we are able to quickly recover from a failure, and we can again tolerate another fault that might happen in the future. Lastly, I want to mention that we also have a flexible fault tolerance, means the customer can decide based on the size of the cluster how much faults he wants to or is willing to tolerate.